Hey everyone, welcome back. So today we're going to dive into a super cool type of number that, trust me, you use every single day, probably without even thinking about it. I am talking about rational numbers. I know, you've heard of whole numbers and fractions, but rational numbers are kind of like the superheroes of the number world. Ready to meet them? Chalo, let's get started. So here's the game plan for today. First up, we'll properly meet rational numbers and find out what exactly they are. Then we'll learn how to give them a little makeover to find the simplest, neatest form. After that, it's action time. We'll add, subtract, multiply and divide them. Then we'll make them face off against each other to see which one is bigger. And finally, we'll unlock some secret rules and really cool facts about them. It's going to be a lot of fun. So let's jump right in. Okay, first things first. What on earth is a rational number? I mean, what makes a number rational anyway? Well, you're about to find out. So here's the big secret. A rational number is basically any number that you can write down as a fraction, p over q. But there is one massive, super important rule you can never break. The bottom number, the denominator q, can never, ever be 0. Why? Well, think about it. If you have one pizza and you try to divide it among 0 people, it just doesn't make sense, right? It's impossible. Now, rational numbers have moods. They can be positive or negative, and it's actually really easy to figure out which is which. If the top and bottom numbers have the same sign, like both are positive or both are negative, then the whole number is positive. Take a look at -4 over -5. The two negatives basically cancel each other out and become a positive. But if they have opposite signs, one is positive and one is negative, then the rational number is negative. Simple as that. Alright, get ready for a little bit of math magic. In this next part, we're going to see how some rational numbers are kind of like shapeshifters. They can look totally different, but their value, what they're truly worth, stays exactly the same. Okay, this is my favorite way to think about it. Imagine you're at a pizza party. You could have one big slice that's half the pizza, or you could have two smaller slices which is 2/4 of the pizza, or even 4 tiny slices which is 4/8 of the pizza. It doesn't matter how you slice it, right? You're still eating the exact same amount of pizza. That's precisely how equivalent rational numbers work. They might look different, but they're all the same on the inside. So how do we create these different looks? It's super easy. You just have to remember one golden rule. Whatever you do to the top, you must do to the bottom. It's all about being fair. If you multiply the numerator by 2, you have to multiply the denominator by 2. If you multiply the top by 3, you multiply the bottom by 3. See, we're just keeping everything perfectly balanced. Now let's talk about getting our rational numbers into what we call standard form. You can think of it like this. It's the simplest, most reduced, best-looking version. A number is in standard form when the numerator and the denominator don't share any common factors except for the number 1. It's a number at its neatest. So how do we get them into this standard form? It's a simple two-step process. First, you find the biggest number that can divide both the top and the bottom number evenly, which we call the greatest common divisor or GCD. Once you've found that number, you just divide both the top and the bottom by it. And that's it. Your number is now in its perfect standard form. Let's try one together. Say we have 16 over 24. We need to find the biggest number that goes into both 16 and 24. Let's think. 2 works. 4 also works. What about 8? Yes, 8 is the GCD. So we do 16 divided by 8, which is 2, and 24 divided by 8, which is 3. So 16 over 24 in its simplest form is just 2 over 3. See, you're already getting the hang of it. Alright, time for the main event. Let's get into the action and see how we can actually use these numbers. We're talking adding, subtracting, multiplying and dividing. Let's do this. Okay, let's start with addition. If we want to add 1 by 2 and 1 by 3, we have a small problem. Their denominators, the bottom numbers, are different. It's like trying to add 1 apple and 1 orange. First, we need to make them the same, so we find the least common denominator or LCD. For 2 and 3, the smallest number they both go into is 6. So we turn 1 by 2 into 3 by 6 and 1 by 3 into 2 by 6. Now we can add them. 3 plus 2 is 5, so our answer is 5 by 6. And you know what's great? Subtraction works almost exactly the same way. You do the same first step, find that common denominator, but then instead of adding the top numbers, you just subtract them. So if we have 5 by 6 minus 2 by 3, we first change 2 by 3 into 4 by 6. Then it's just 5 minus 4, which is 1. The answer is 1 by 6. Easy peasy. Get ready for the easiest one of them all. Seriously. For multiplication, you don't have to worry about common denominators or anything. You just multiply the tops together and multiply the bottoms together. That's it. So for 2 by 3 multiplied by 4 by 5, we just do 2 times 4 is 8 and 3 times 5 is 15. The answer is 8 by 15. Told you it was easy. Now for division, there's a really cool trick. I call it flip and multiply. You keep the first fraction exactly as it is, you change the division sign to a multiplication sign, and then you flip the second fraction upside down. So 2 by 3 divided by 4 by 5 becomes 2 by 3 multiplied by 5 by 4. Now it's just a multiplication problem, and that gives us 10 by 12. Just remember the trick. Flip the second one and multiply. Ding ding ding! It's time for a maths showdown. In this corner, we've got one rational number, and in the other corner, another. But which one is bigger? Who is the champion? Let's find out how to tell.
So the trick to comparing is once again to make the denominators the same. It makes it a fair fight. Once they have the same bottom number, all you have to do is look at the top numbers, the numerators. Whichever one has the bigger numerator, that's the bigger number. Let's see this in action. Who's bigger, 2 by 3 or 4 by 5? Well, let's find a common denominator. 15 works, so 2 by 3 becomes 10 by 15 and 4 by 5 becomes 12 by 15. Now we just compare the tops. Is 10 bigger or is 12 bigger? 12 is bigger, of course, so that means 4 by 5 is the winner. Another way to see this is on a number line. Think of the denominator as telling you how many equal jumps to make between 0 and 1, and the numerator tells you which jump to land on. And here's the most important rule of the number line. Any number to the right is always greater than any number to its left. Always. Okay, we've covered a lot, but now it's time to open the treasure chest and find some of the secret rules and really mind-blowing facts about rational numbers that make them so cool. So check out some of these properties. Closure just means if you add or multiply two rational numbers, your answer's guaranteed to be another rational number. It's like a VIP club. Commutative means the order doesn't matter for adding and multiplying. 2 by 3 times 1 by 2 is the same as 1 by 2 times 2 by 3. Associative is about grouping. It doesn't matter which pair you calculate first. And my favorite, the multiplicative inverse. This means any rational number multiplied by its flipped version always equals exactly 1. It's like magic. Okay, get ready for this because this fact is awesome. Between any two rational numbers you can think of, there are actually an infinite number of other rational numbers. I'm not kidding. It's a never-ending chain of numbers. For example, between 1 by 4 and 1 by 2, you might think there's nothing there. But if we call them 2 by 8 and 4 by 8, you can see 3 by 8 sitting right there in the middle. And you can just keep going forever. How cool is that? So let's wrap up with 3 key things to remember. First, every single integer you know, like the number 5, is also a rational number because you can just write it as 5 over 1. Second, they can be positive, negative, or 0. And third, when you write them as decimals, they either stop neatly, like 0.5, or they repeat a pattern forever, like 0.3333. You guys were absolutely brilliant today. We've covered so much about rational numbers. You now know what they are, how to simplify them, and how to do all the operations with them. You are officially a rational number expert. Keep practicing and you'll be a math superhero in no time. I'll see you in the next one.